Hi everyone, my name is Yi. I'm your host for Occupational Medicine Pearls podcast. This episode is a mix of safety relevant topic, but let's start with safety data sheets. So safety data sheet is a standardized document prepared by the manufacturer or the importer of a hazardous chemical, and it provides information on the chemical's identity, hazards, safe handling, storage, emergency procedures, and disposal. It is a primary hazard communication tool in the workplace under the work health and safety regulations. Previously, it was called Material Safety Data Sheet, and nowadays we simply call that as Safety Data Sheet. Who must prepare an SDS in Australia? All the manufacturers and importers of hazardous chemicals who are supplying to the workplaces, and the PCVU must ensure the current SDS are available at the workplace. However, there are exemptions. So chemicals in the battery incorporated in the plants, fuel, oil or coolants in the container fitted to vehicle for their protection, domestic portable fuel burning appliances, portable firefighting or medical equipment chemicals, refrigeration system in the freight containers, portable liquids in consumer products at retail, and food and beverages packaged for human consumption. That will be interesting. Generally, there are 16 sections of an SDS, and certainly we do not need to remember all of them or know what are they. However, we have to find which sections are the most relevant to healthcare professionals, starting with identification. What is this chemical about, and what is Australia emergency contact? That include both during business hour and out of hour if we want to call and find out about this chemical. Hazard 2 is important since it is hazard identification. It mentioned about GHS classification, pictograms, signal work, hazard and precautionary statements. Section 8, exposure control, tells us about workplace exposure standard, biological exposure indices, engineering controls, and PPE requirements. This sounds fairly important to what we do. Section 11 is about toxicological information, and that happens when people get exposed to it. Maybe 15 is regulatory information, so that is also important what type of chemical that is. The key here is the SDS must use Australian metric units and at least must be used in English. After that, we need to know what is globally harmonized system. Otherwise, we would not be understand what this SDS is about, since that system is used on safety data sheet to convey information about the hazards. GHS is a United Nations system for standardizing the classification and labeling of chemicals worldwide. Australia adopts GHS through Work Health and Safety Regulations, and GHS label must include 1, 2, 3, 4, 5, 6. So 6 components. So things like product identifier, supplier identification, signal words, because this is important. There are 2 signal words. One is danger. Danger is more severe than warning, and warning is less severe. Just kind of need to remember. So if you think about D is before W, so D is more dangerous. So danger is used for more severe hazard categories, things like acute toxicity category 1 to 3, carcinogenicity cat 1A and 1B. Warning is for less severe hazard categories, so acute toxicity cat 4 and higher, carcinogenicity cat 2. The other component of GHS label are hazard pictograms, which we love, hazard statements, and precautionary statements. There are also an exemption for very small containers. So when the container is so small, so you can get away with not including all the information on the labels. In that instance, you have to include the most dangerous and most important bit. There are 9 pictograms. It is important to know what are they to identify. Most of them are quite self-explanatory. One thing we do not want is that skull bone and crossbone. So that is acute lethality and toxicity. And there are a few different classifications. The GHS, if you want to read it, like for me, things like acute toxicity, important skin corrosion, eye damage, respiratory sensitization, skin sensitization, xenogenicity, reproduction toxicity. They all seem to be important to know what they meant. After GHS, let's go to IARC carcinogen classification. IARC is a part of the WHO based in Lyon, France, and it published the IARC monographs, which evaluate scientific evidence on carcinogenicity of agents to human. Since 1971, there are over 900 agents that has been evaluated. For us, what we need to know is that IARC classify hazard. The question is, can it cause cancer? It doesn't quantify the risk. That is what people confuse about. If you think someone can cause cancer, almost anything or many things can cause cancer, but what are the risks? Well, it depends on the dose. So IARC classification doesn't tell how likely to cause cancer at a given exposure. Example would be group 1 agent with very low exposure may pose negligible risk, while group 2B with high exposure could be more concerning in practice. Even if we compare about asbestos, if it is not disturbed, stay in the wall, and we can live in the room without any problem. But if you spend all the time outdoors, the UV light will cause skin cancer first. If we are looking at IARC classification, group 1 is carcinogenic to humans, and there is sufficient evidence that causing cancers. Group 2A is probably carcinogenic to human because there are limited evidence in human, but there is sufficient evidence in animals or strong mechanistic evidence. So things like inorganic lead compound, acrylamide, shift work, glyphosate, creosote, and bitumen. So these are category group 2A. Group 2B is that possibly carcinogenic to human, and there are limited evidence in human research and limited evidence in animals, or inadequate in humans. So it may include like extremely low frequency electromagnetic field, styrene, titanium dioxide, cobalt, metal without tungsten carbide. So they could be under 2B. Group 3 is not classified as carcinogenicity to human, so that's not really important, but if you want to know, caffeine is in that group. There is also historically group 4, but we do not use that in our context most of the time. If we compare with GHS carcinogenicity category, so with the GHS, they have category 1A is the same as IARC group 1. GHS category 1B is similar to IARC group 2A, and GHS category 2 is IARC group 2. And there is no class or group category 3 in GHS, but there is group 3 in IARC. So that is very approximate mapping system. Alright, so what are the limitations of SDS? That is also important. Quality is variable, and it is only as good as the data that manufacturer provides, and sometimes they may not include them for trade secret, or they just don't regard that in that particular context of testing that would be sufficient enough to cause harm, and may lack specific workplace exposure standard if prepared overseas, or may not include any workplace exposure standard at all, and may not include latest IARC or GHS classification. Phrases like may be dangerous or safe under most conditions are not really that useful if you're trying to help with someone with acute exposure. And the last of all is that SDS doesn't replace a proper workplace risk assessment and proper clinical assessment if we are managing acute toxicity. That's all for today. I hope you find this episode useful.